In this lesson, we're going to be learning about domain and range, which are very important characteristics of all functions. The goal is that you'll be able to state the domain and range for a given relation. So your question might be, what is a relation? A relation is a set of ordered pairs, x and y values. So as we can see here, we have three different ordered pairs, 3, 2, 4, 6, and 7, -1. These are going to be a relationship because they're going to relate to each other, making a function. Now, we're going to define a very important word, domain. It is the set of x values. So from now on, whenever you hear the word domain, I want you to immediately think of x. Domain, x. So given my ordered pairs we saw before, I would be looking at their x values. And as we know, in an ordered pair, x values come first. So to write my domain, I would just take those x values. And we're going to learn in a moment all of the details that go into writing that domain. The main important point I want you to take away right now, domain is your x values. We're going to use brackets whenever you're listing things. So one thing that you'll notice in both your domain and your range is since we're listing values of either x values or y values, we're going to have a bracket to start and end our domain and range. So what is range? Range is the y values. You probably could have seen that coming. So of course, in my ordered pairs, I'm focused on the y values, which is going to turn into my range. So how do you state the domain and range? Well, the first thing is to use those brackets we talked about earlier. Whenever we're listing something, we need to make sure we include it inside of brackets. Then we're going to list the values from smallest to largest, which is also known as least to greatest. Lastly, we're going to make sure that there aren't any repeating numbers. And we'll see how that works when we go into our first example. If we had repeating numbers, so we want to have no repeating numbers. So for example, 1, 2, 3, 4, 5 is totally acceptable. But if I had 1, 1, 2, 3, 4, that would not be a correct answer because my ones are repeating. So I want to make sure I do not repeat any values for either my domain or my range. So first we're going to take a look at stating the domain and range for a table. Domain, x values. Domain, x values. That should happen automatically. I say domain, you say x value. So we go back to our notes to see how do we state domain and range. We know we need to start off using brackets. So we set up our domain in our two brackets. Then we're going to list the values from smallest to largest, least to greatest. So I know that when I'm looking at my x values, negatives are always going to be my smaller numbers. So that's actually what's going to start us off, is that -2. Can you think of what numbers come next in order from least to greatest? We get our 1, 3, and 5. Something important to notice, we had 2 3s in our table, but only 1 3 made it into our domain. And that's because the last part of our rule, we do not repeat numbers. Once 3 is represented in our domain, we do not need to represent 3 anymore. So now we're going to take a look at this problem from the point of view of the range. Just like with domain being x values, every time you think range, you should automatically think y value. Range, y value. Range, y value. So going by our rules, the first thing we need is a set of brackets. And then we're going to list our values from smallest to largest. Now notice there were a lot more values inside of my table than made it into my range. I start off with my -4 because that's my smallest value, and then I work up to 2, which is my largest value. The reason you only see 2 of them is because of the last rule of not having any repeated numbers. So even though there were 3 -4s, I only list 1 of them in my range. Likewise with the 2, even though there were 2 of them, only 1 makes it into my answer. And there you have the domain and range of this table. Take a look at example 1. What should you think of when you think of domain? Domain should make you think of your x values. Do your best to write your domain. Check your work. So we're following the steps. We know we have to have brackets. We know we're listing the values from least to greatest, which is usually pretty easy with your x values because they typically come in order, although you always need to check. And of course, they do not have any repeating numbers included in your domain. And then just keep in mind, if a domain did repeat, it technically would be not a function. Next, we're going to talk about range. What should you be thinking of? Y values. Checking our work, try your best with the range. We've got our brackets. Now we've got it listed from least to greatest, and we do not have any repeating numbers. This one had a lot of repeating numbers, but again, you just want your final answer to have all the numbers from least to greatest and no repeating values. Now we're going to take a look at finding the domain and range from a graph. Well, right now I have a set of points, and we were comfortable with finding the domain and range in a table. We can continue to use that table method if we take those points and identify their ordered pairs. So for example, the first point on our graph is at -3, 4. That means it's 3 to the left at the origin, and it means it's up 4 from the origin. So we're at the point -3, 4. And that's going to be the first entry on my table. Can you try the next value that should go in our table? Hopefully you saw that -2, 1 is our next value in the table. We then have 0, 2, and 0, -2. And that's followed up by 2, -1, 4, 0, and 4, 2. And there we have a table in which we can write our domain and range. Go ahead and try your best on the domain. Check your work. Our domain are our x values, which put in order from least to greatest with no repeating is -3, -2, 0, 2, and 4. Try your best for the range. So we should have seen -2, -1, 0, 1, 2, 4, putting in order from least to greatest with no repeating values. So here you have your domain and range from the graph using a table method. If you're a person who likes to save time and you don't want to write a table, another option you could have is to use, when we're talking our domain, we're actually going to be using a vertical line. And this vertical line, we're going to be reading left to right. So we come in, stop, we hit a point. We find the x value. Well, it's 3 to the left of the origin, so we're going to get -3. My next one is at -2. Then I'm at 0. Then I'm at the x value of 2. And then I'm at the x value of 4. And there I was able to find the domain of the x values by using this vertical line and just moving it through as I check all of my x values from left to right. Likewise, I could do the same thing for my range. The only difference is I'm going to be reading it from bottom to top. So if I take this from the bottom and I move, once I hit my first point, I know my range has begun. It's at -2. Moving up, it goes to -1, 0, 1, 2, and ultimately ends at 4. So again, I'm able to use that as a way to just check my values as I'm reading left to right for my domain and up and down for my range. Now we're going to talk about the domain and range of continuous graphs. In order to do that, we need to go over interval notation. For a domain, you're looking for your minimum x value and your maximum x value. Likewise, for range, you're looking for your minimum y value and your maximum y value. In order to understand the domain and range of graphs, we need to understand the concept of infinity. You might be familiar with infinity. To infinity and beyond. And knowing that infinity goes on forever and ever and ever. But you might not have thought about the fact that there's actually both a negative and a positive infinity. If I have a number line, and I have my number starting centered at 0. If I go to the right, I'm going to have all my positives, 1, 2, 3, 4, 5, on and on and on. And on my left, I'm going to have my negatives, which is going to be -1, -2, -3, -4, -5, on and on and on. Well, if you ever wanted to chase that on and on and on, you would find infinity at both ends of the spectrum. If I continue all the way to the left, going incredibly small, I eventually would reach -infinity. Although the joke's on you, you never actually reach it. You just approach -infinity. That means you get really close. Same on the right side, if I kept on going, 6, 7, 8, 9, 10, a billion, a million, infinity is the number that we would eventually hit on the right side of the spectrum. That's important when we're talking about domain and range, because my x values all the way to the left are -infinity, all the way to the right are positive infinity, and likewise with my range, all the way at the bottom is -infinity, and all the way at the top is positive infinity. So we're going to talk about some new symbols to help you out with interval notation. The first value you're going to list is your minimum value. The second value you're going to list is your maximum value. That's where you start and where you stop. Just so you know, if you have a bracket, that means that answer is included. It means you actually touch that part of the graph. But if you have a parenthesis, it means it's not included. That means that you get really, really close, but you never actually touch it. It's very similar to the open and closed dot that we used in inequalities, which is something we're also going to talk about in this lesson. Then, of course, if we were interpreting this, that would mean that the minimum value is part of the graph because it has a bracket and it's the first value, so it's a minimum. Also interpreting it, we would see that it means that the maximum value is not part of the graph because our second value is our maximum value and it's a parenthesis, which means it's not included. That will make more sense when we get some examples. So let's take a look at example 3. What is the minimum starting value reading left to right? Well, hopefully you saw that the first point you come to is the open dot 0, -3. So then the next question, what is the maximum ending value reading left to right? So of course, we would see this to be the second point at 4, 0. Now coming up with the domain means we're focusing on the x values. Domain x, domain x, x domain, domain x. So my question for you is, which one do I list first? What's the minimum x value? Again, we're reading from left to right. So that's going to end up being 0. So then what's my maximum x value? 4. Now that I know my minimum and my maximum values, we need to talk about brackets or parentheses. Is the starting point open or closed? Since we see that it's open, it is going to be not included, which means that it is going to have a parenthesis. The next question is the ending point open or closed? Well, I know that it's a closed dot, which means it is included, which means we're going to use a bracket. So our final domain is going to be 0, 4, because those are my two x values in the order of least to greatest. And it's going to have a parenthesis because it started at an open dot, which is not included, and it ended at a closed dot, which is included. Next, we're going to talk about the range. Try your best to write your range and check your work. What is the minimum y value? -3. What's the maximum y value? 0. Again, we're reading from the bottom to the top. So then we're going to have, what type of notation do we need? Parentheses or brackets, one of each? Hopefully you should have seen that they're the exact same as our domain because our points are exactly the same. We have a parentheses because our first dot is open, and we have a bracket because our second dot is closed. And there is our domain and range for this example. Let's take a look at the next graph. Where does the graph start and where does the graph end? Reading left to right. Well, reading left to right, it starts at this open dot, -1, 4. This is where you might have gotten tripped up, but where does the graph end? It actually ends with this arrow, this downward pointing arrow, slanted to the side, so it's pointing down and to the right. You might have thought this second dot here is where it ends, but while yes, that is an important feature of the graph, it is not actually part of the domain and range, because domain and range is all about where the graph starts and where the graph ends. And in this case, we're ending with this slanted green arrow. If I was to take a look at that green arrow, I know it's going to the right, which I know goes towards positive infinity. But it's also going down, which is my range direction, and that downward direction is towards negative infinity. So if that green arrow continued on and on and on forever, it would approach positive infinity to the side, and it would approach negative infinity to the bottom. So that's going to actually make the point positive infinity, negative infinity, which will help us with writing our domain and range. So try your best to write your domain. Think about your parentheses and your brackets. We're at -1 as our starting x value, and positive infinity would be our eventual ending x value. It's going to have an open dot, so that's why there's a parenthesis, and you can never, ever touch infinity. You can never touch infinity. Can't touch this, right? Can't touch infinity, so we're always going to use a parenthesis when it comes to infinity. Always, always. Try your best to write your range. One thing that might have happened with your range is you might have listed it as for negative infinity, but you got to remember your answer needs to be least to greatest. So from the bottom of the graph, I'm going from negative infinity, because that's where that eventual green arrow would go, is towards negative infinity down. But when I go up is when I hit I hit 4. So that's why I'm at negative infinity and 4. The same thing applies for it being parentheses because of the open dot and the infinity. Oh, check it. It looks good. Domain and range. Let's go ahead and try out example 4, first graph. So hopefully you would have seen that you're at negative infinity, positive infinity for your domain, as well as being at negative infinity, positive infinity for your range. Let's talk domain first. Domain, again, is going left to right. I know that all the way to the left, I have negative infinity. And if I look at the graph, I know that if it was to continue going, it would eventually approach negative infinity all the way to the left. There's no sign of stopping. Same thing with the opposite side of the graph. It's going to continue to go all the way, eventually approaching positive infinity to the right. So that's where I know that I don't have any stops. So I'm going to have my negative infinity, positive infinity for my domain. Looking at my range, I'm reading the graph from bottom to the top. And I know that looking at this bottom arrow, it would eventually keep going. And as it goes down, 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 it approaches negative infinity. And likewise, when I'm going to the opposite side of the graph, when it continues to go, it goes up, up, up towards positive infinity. So that's why my domain and range are both negative infinity to positive infinity. Notice how they both have parentheses because you cannot touch infinity. Never, ever, 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 no matter how hard you try. Go ahead and try your best on example 4. Got you again. It's negative infinity to positive infinity for both of them. It doesn't matter how many twists or turns the graph has. All I'm looking at is where the graph starts and where the graph ends. And when it starts with an arrow that goes on forever, even though it might look like it's going pretty straight, it still is slightly slanted, and forever is a long time for a graph to go on. So that's why it's going to be at negative infinity towards the right and at negative infinity at the bottom. And then likewise, as it continues on up, it's going to positive infinity and positive infinity, both in the upwards and to the right direction. We're going to go ahead and do some extra examples. You might not have these in your notes, so just find a spot to write these down. Here's a hint. Remember that the graph is continuous, so we only care about where it first starts and finally ends. So try your best to write the domain and the range. So for domain, we're looking at the values when it's going left to right. It starts at negative infinity with this arrow over here, and then it also ends at negative infinity with this arrow over here. So our domain is pretty straightforward. Again, it doesn't matter what's happening with these dots and disconnected. All I care about is where it starts and where it ends. Next, we're going to look at the range going from the bottom to the top. Now, from the bottom, I don't have any arrows that are pointing down. These lines are going completely horizontal, so they do not go down at all. So I'm only looking at my lowest value to my highest value, -3, and to 5. -3 is an open dot, and 5 is a closed dot. So I have my parenthesis for the open dot and my bracket for the closed dot. Again, the reason why there is not any infinity in my range is because these arrows are completely horizontal. If they had been slanted up or down, that would have made my range be a positive or negative infinity. But since I don't have a positive or negative infinity, an arrow going forever down or an arrow going forever up, I'm just looking at the values. My lowest value, reading from the bottom, is -3, and my highest value, reading from the bottom or going to the top, is going to be 5. Last extra example, you've got a little bit more stamina. Hang in there. We got this. Try your best. We've got -infinity to infinity for my x's, and then -infinity to 7 for my range. For my domain, it's -infinity up here because it's a completely horizontal arrow going all the way to the left. We still have an arrow going to the right, so it will eventually approach positive infinity, but the arrow is slanted, which means that it is also pointing forever down, which is towards -infinity for my range. And then my highest value that I reach is going to be 7, closed dot to make the bracket. And the only reason it doesn't go on to positive infinity up is because this arrow is horizontal. It does not slant up, so it does not go towards infinity. You did a fantastic job hanging in there for these notes. Now go ahead and apply yourself as you complete the practice to show what you know. I promise if domain and range is confusing now, it will get better every bit of practice that you put in. And don't forget to always be awesome.